Hello and welcome. My name is Ellie and I'll be beginning the presentation. We are talking about our bus rapid transit line for HRM that we've spent the second half of the semester designing. Here is our agenda for the day. I'll give you a chance to briefly look at that now. So to get started, I'll start with a general introduction. Our objective is to design the most efficient BRT line in order to compete with private vehicle travel time. With the BRT line, we attempted to connect critical locations across the peninsula and Dartmouth. These locations were identified as Dalhousie campuses, hospitals, and existing transit hubs. Throughout this presentation, we will discuss our thought processes in planning the BRT line, in addition to policy, technology, branding, and budget as it pertains to our design. In terms of land use and policy context, we consulted several documents. These included the Integrated Mobility Plan, the Center Plan, packages A and B, the Rapid Transit Strategy, the Regional Center Plan Area Land Use Bylaw, and the Dartmouth Community Plan. So our design fits within the guiding principles and policies of the aforementioned documents. Firstly, the IMP's goal of 30% of total trips in HRM being made by active transit and busing. Secondly, BRT reduces emissions. The Integrated Mobility Plan wants to reduce emissions by 30% by 2020. It's unclear whether this target has been met, but a BRT line can help contribute to this reduction. Thirdly, BRT lines lower costs for residents of HRM. According to the IMP, owning a car can cost up to $10,000 a year, while public and rapid transit can cost about $1,000 a year. That's a savings of 90%. Additionally, to these concrete measurable goals, there are some less tangible goals. Firstly, the Center Plan wants to improve health and well-being through planning interventions, including mobility choices. Adding another mobility choice for residents of the HRM lines up specifically with this goal. Secondly, Center Plan wants to increase density and public transit usage. Having a strong BRT can help to reach this goal. Our thinking is that more people will want to live in the center if the transit is really reliable and affordable. This helps the Center Plan's goal of densification.
When considering our design, we looked at a lot of different questions, some of which you can see on the screen. What is the zoning for the land we want to put the Lancaster terminal? Does rapid transit fit into the current plans? Do we need to change plans in order to accommodate our design? Does our design need to be changed in order to accommodate existing plans? In terms of the Lancaster terminal, we found that the land was zoned higher order residential. This permits mid-rise multi-unit dwellings, townhouses, stacked townhouses, supportive housing, and single and semi-detached dwellings. As such, this would require an amendment to achieve our goals. Given that one of the objectives of the IMP and Center Plan is to get people out of their private vehicles, a bus system that currently takes 4 times longer than it does to drive from the Burnside business area to Scotia Square in downtown Halifax, it's clear that we need to make an improvement. The bus takes anywhere from 52 to 67 minutes, or 15 minutes to drive. This definitely doesn't encourage drivers to start taking transit, so it's no wonder that people would choose to drive this route. BRT can address these objectives. These are 2 options we considered early on in our route selection process. Ultimately, we decided these options would not fully meet the needs of transit users in HRM. These 2 options fell short on key goals of our BRT as established by our team, such as access to the downtown or to Dalhousie campuses. According to the National Association of City Transportation Officials, NACTO, BRT Service Design Guidelines, a successful BRT route will hit many important areas in the city center while also competing with private vehicle travel time. This picture shown here is a screenshot from the first iteration of our final route. We refined this to accomplish our objectives. We identified places of significance that transit users in Halifax will most likely need to get to and from, including residential areas, hospitals, university campuses, and the business districts. Out of our 3 potential routes, we concluded that our second option, the one you see above, finds the balance between low travel times and priority stops in one single route. Further analysis was required to finalize our route choice, which we will discuss in further detail throughout the presentation. Conclusively, the above image shows a route which addresses our major objectives,
such as those mentioned by NACTO and municipal departments, as well as our significant destinations.
Thanks, Tim and Ellie, for explaining the policy context of our BRT proposal. My name is Walter. In the design of the BRT line, we must balance its speed against the infrastructural costs and its impact on other road users. Therefore, the BRT will share the existing road systems to minimize costs. Specifically, with only 3 lanes, the bridge is a key bottleneck of the line. This means that we can have at most 1 dedicated BRT lane for only 1 direction at a time. To minimize traffic impact, this dedicated lane will also allow for any vehicles with more than 2 people. On wider streets, such as Quinpool Road, we will eliminate street parking and add a bus lane and bike lane in each direction. With the BRT line replacing private vehicle use, parking on the intersecting streets will suffice. We also expect this type of streets to become less congested while more lively with more pedestrians, as more people benefit from the BRT line and gain easy access to these neighborhoods. Streets such as Barrington and Cottingen are narrower and have limited number of lanes, yet at the same time are critical places for the BRT to serve. Our solution is to turn these streets into transit priority streets, rerouting other vehicles to adjacent streets. We expect this strategy to ease traffic congestion as users switch away from private vehicles. Also, as these streets become more transit-oriented, they are set to become pedestrian destinations, boosting businesses there. As much as we hope the BRT to serve all key destinations, in some instances, doing so would add significant travel time, undermining the fundamental goal of speedy transportation across town. Here, the IWK stop is still 700 meters from the center of Dow University before the BRT continues onto Roby. So, we implemented a targeted multimodal strategy where Dow users can easily and seamlessly take out a bike from the integrated bike docking station, cycle to the center of Dow, and return the bike at the docking station there. On the topic of customer experience, we propose an information display at each BRT station. At one glance, the map clearly shows when buses come and where they go, most prominently showing the next arrival time of the BRT. We think this will ease a lot of anxiety and stress related to waiting at the bus stop. This information display system is enabled by a host of hardware that communicates with one another. On buses, GPS devices collect location data and send them to the central control center. The software then takes this data and converts it into arrival times for each bus station, updating the information display in real time. One of the factors that slow down the BRT compared to an underground rail system is the need to navigate street intersections. To minimize their negative effects, we propose signal controls at the intersections, where they detect an approaching BRT and change the traffic light to green until after the BRT passes. Now, Vanthian will speak more about the technology that we use to collect fares.
Thank you, Walter and Vanthian, for talking about the technology of our BRT system. My name is Josh, and I'll be unveiling the brand identity of our Halifax Rapid Transit proposal. First, I'll talk about the existing Halifax Transit branding. Identifiable in its colors and pattern on the bus wraps and the distinct X displayed on the side of all buses, shades of blue and yellow unmistakably define Halifax's local bus system. Throughout all marketing materials, these colors, lines, font, and styling consistently present a reminder to the public of the city's dependable transit system. It is important to recognize these characteristics as key in maintaining its identity throughout the HRM. Our proposed logo builds on the aforementioned brand recognition implemented in the HRM. Our logo design for Halifax Rapid Transit ties closely with the existing Halifax Transit branding strategy with the use of font and color combination. This provides instant recognition as a public transportation service for Haligonians, while a stylized bus vector indicates a fast-moving and modern vehicle, a type previously unseen in Halifax. The HRT acronym recalls a common term HRM, while differentiating itself from the more common BRT used in other cities. The low-emission, hybrid-powered, 60-foot articulated bus fleet is skinned in the Halifax Transit blue and yellow, but with the addition of a contemporary electric blue to distinguish the vehicles as leading edge. The modern curves of the vehicle are accentuated by the brightly colored wrap, meant to evoke ideas of speed and high-quality train-like service. Wheel covers help streamline the vessel's shape, while the HRT logo is modestly displayed at the front and above the oversized windows. Not shown in this image is the ability to transport bicycles on the front as well as inside in the mobility vehicle stowage. Two standard types of floor heights exist for fleet vehicles. Both allow for at-level boarding, but our choice to select a low-floor vehicle uses a platform 50 centimeters lower, which is easier to integrate into the public realm. This means station platform heights are only approximately 8 inches above existing curb height, providing easier access for riders of all ages and abilities. Inside, round edges and high-quality, color-coordinated finishings continue HRT's theme of mimicking a high-speed train. Extra-wide doors with a low-floor option at 14 inches, which provide ADA requirements for efficient boarding and alighting. As such, seating is arranged to maximize standing room during peak hours, with dedicated areas illuminated in blue on the driver's side to accommodate wheelchair, stroller, and accessible vehicles. 3 sets of doors open on the passenger side, all equipped with QR code readers and real-time passenger count. Stowage shelves that sit over all wheel wells accommodate passenger baggage, and information displays present data such as arrival time, next destination, GPS location of the vehicle, and passenger information. Large windows sit low to increase perceived roominess and to allow for passengers to be aware of their surroundings and enjoy the scenery that Halifax has to offer. Next, Jialin will discuss how we design the stations.
My name is Jialin. I work together with Josh on the station and terminal design. As we learned from Walter's runway research, the side platform station is the best option fitting into Halifax road condition, which saved a lot of road space and provide easier and safer access to passengers. Here I pick the public library stop as an example to test our design ideas. The BRT station gives people the first impression of the total transit experience. A successful BRT station should provide people a fluent and comfortable experience to meet different needs at different times of the day. Also, it should respect the street condition and work together with other transportation methods. The configuration of stations has 2 components, the station layout on the street curb and the layout of the passenger boarding area. Our HRT buses are 60 feet long, so we need a 75 feet passenger loading zone. And as well, the bus shelter should be no shorter than 45 feet. Here are the design features we want to include in our HRT station design. We want to provide a premium experience for the riders as well as bring a unique identity on the street. I will explain in detail in the following slides. This is how does our shelter look like during the nighttime. The brand identity is strengthened by the strategic placement of the HRT logo and the color-coordinated lighting within the station. The lighting strategy increases comfort, safety, and ambience during winter and evening hours. This is how does our station look like during the daytime. Accessibility is very important for our design. It has the designated bicycle path and covered parking as well as a wide ramp for wheelchair and micromobility use. The high-quality seating within the enclosure is attractive and modern, while the porosity of the walls allows for quick and efficient circulation. About our terminal design concept. We picked the Burnside terminal as an example to test our design thinkings. It's located next to the Greater Burnside Business Association and the crossroad, which is made by the Burnside Drive and White Avenue. It's not only the place for transit, but also a place for social and relaxing. This is our intention behind the design. People could go outside to enjoy the park with their family when they are waiting for a bus, or they can stay inside during the winter time. The warm and covered terminal will make them feel like home. This terminal also has a designated area for parking and maintenance to serve the whole BRT transit system.
Hi, this is Vanthian, and I'm going to start talking about the budget forecast. So the budget for the BRT system that we have designed involves something called a capital cost, and the capital cost would be incurred for the development of infrastructures, the control center, the IT aspects, and the fare collection module that we're going to be putting in place. So when it comes to infrastructure, it totally depends on the parameters like road purchase and upgradations, construction of terminals and bus stops, purchasing vehicles and modifications of the vehicles. And second comes to control centers, where we need to set up the computers, the communication networks, servers, screens, biometric readers, and I mean this is totally put in place to aid optimized operation of the BRT. And when it comes to the information technology aspect, we would definitely need a GPS system to keep track of the vehicles, the fare collection and ERP software, which keeps a track of how the fare collection happens and the accounts and stuff, a scheduling system which is used to schedule the vehicles, a POS for the payments, a web portal which is very much required at the present generation to have an interaction with the users, data transfers and backup, report generation and cybersecurity aspects. And when it comes to fare collection module, the ticket printers, card validators, POS machines, the access control barriers, servers, UPS, and other related things which involves the collection of fare for, say, printing of tickets or loading of money into the RFID with those aspects. So these are the four major components of the capital cost, where this would be involved in the beginning of the construction or establishment of a BRT. Once the BRT starts functioning, there are costs involved with the operations and maintenance part of it, so which includes the operations cost, which wholly includes the payroll of salary to the employees and for the fuel. And when it comes to administrative cost, it is incurred through like the insurance, taxes, the marketing amount that we spent on the housekeeping, security and electricity bills that we had to pay. And the infrastructural cost, this is something different from the one that is mentioned in the capital cost. The cost incurred in the infrastructure mentioned here is for the maintenance involved with the terminals, stations and vehicles and other related activities. Whereas for the IT cost, it involves the maintenance of servers and IT related equipments for, say, upgradation of any website, or if there is something that is to be addressed. So all these things are involved in the IT cost. So these costs are the one that comes into play once the BRT system is set in place.